Question number 7. The curve and the line given by the equations. So we are given this as a quadratic equation. This is a linear equation. K is a non-zero constant and the curve and the line intersect at a single point. This is a very important point to note. When a curve and a line intersect, the first thing that we infer from this is that we need to solve them simultaneously. So when we solve simultaneously, we find the coordinate of point of intersection. That is one. Second is when the question says they intersect at a single point, that means that their discriminant b squared minus 4ac must be equal to 0. So let's start by looking at the equations. This is our quadratic equation and this is our linear equation. When we solve simultaneously, we take any one variable from the linear equation, make it the subject of formula and plug it into the quadratic equation. So let's do that. Let's make y the subject of formula as it is convenient. Y is equal to 1 plus k by 2x. Now this value of y, we can plug it in here for y and hence solve the two equations simultaneously. So let's do the plugging in. We have kx squared minus x into the y value, which is 1 plus k by 2x plus k plus 1 into x is equal to 1. Opening our brackets, we have kx squared minus x minus k by 2x squared. Here the x will multiply with both the terms, so kx plus x negative 1. As 1 goes to the left, it becomes negative. We can simplify the like terms. We have 1k x square minus half kx square. So that will give us half kx square. We have minus x that cancels out x, and we have plus kx minus 1 is equal to 0. So we got the first point where we have solved them simultaneously. Second is, since they have one point of intersection, we need to now write the discriminant b square minus 4ac equal to 0. So let's write values of a, b, c. A is equal to half k, b is equal to k, and c is equal to negative 1. So the discriminant is b squared, which is k squared minus 4 into a into c, and that should be equal to 0. Cancel out 2 ones are 2 twos are, and here the minus and minus make it plus, so we have k squared plus 2x is equal to 0, plus 2k is equal to 0. We can factorize to remove k common out. K plus 2 is equal to 0. Therefore, k is equal to 0, or k plus 2 is equal to 0. Therefore, k is equal to negative 2. Now, the question says that k is a non-zero constant. Hence, we rule out k is equal to 0. Therefore, we have got the value of k as negative 2. Now, for the part B, question says give the coordinates of the point of intersection of the line and the curve. So we have already got the simultaneous equation where we have solved them simultaneously and simplified them, and this is the equation. All we need to do is to plug in the value of k that we got. So for the part B, we have half kx squared plus kx minus 1 is equal to 0. So let's plug in value of k, half into minus 2x squared plus, this will be minus because 2 is negative, minus 2k minus 1 is equal to 0. The 2 and the 2 will cancel. We have minus x squared minus 2k minus 1 is equal to 0. Now our product is coefficient of x squared into the constant. So the product is 1. Sum is -2. The numbers are -1 and -1. Splitting the middle term, we have x squared minus 1x minus 1x minus 1 is equal to 0. Take common from the first two terms, minus x into x plus 1, and here minus 1 into x plus 1 is equal to 0. So we have minus x minus 1 as one bracket and x plus 1 as the other bracket. Equating both to 0, minus x minus 1 is equal to 0, x plus 1 is equal to 0. So minus x is equal to 1 or x is equal to -1. Here also we have x is equal to -1, which should be very much the case as we have one point of intersection. So we should have a repeated root and both x values should be the same. Now we can find the corresponding y value, and we have our equation for the y. Y is equal to 1 plus k by 2x. So y is equal to 1 plus k by 2 into the x value. Therefore y is equal to 1. The k is -2. So 1 plus, we can write -2 by 2 into -1. So this gives us -1. -1 into -1 give us +1. 1 plus 1, answer is y is equal to 2. Therefore, when x is -1, y is 2. And that answers part B. Moving on to question number 8. Question 8 says, give your answer in set notation, solve the inequality. So the first inequality is 3x minus 8 is greater than x plus 13. When we solve an inequality, it is just like as if we are solving an equation. The only thing is, if we multiply or divide by a negative number, the sign of the inequality reverses. So until we do that, we can just work it out normally. We have 3x minus x is greater than 13 plus 8. So 3x minus x gives us 2x. 13 plus 8 will give us 21. Therefore, x is greater than 21 divided by 2. X is greater than 10.5. Since we have to give answer as a set notation, so we will write it in terms of a set. X is such that x is greater than 10.5. And that answers question A. Moving on to B. Solve the inequality. We have x squared minus 5x minus 14 is greater than 0. So this is a quadratic inequality. To solve a quadratic inequality, we equate it to 0 to find the critical values. So we equate the expression to 0 here. And this is to find the critical values. So our product is -14. Our sum is -5. So we have 7 2s are 14, +7, -2. Oh no, it's going to be the other way around because the sum is negative. So -7 and +2. 7 2s are 14, yeah. So we can write our brackets x minus 7 and x plus 2 is equal to 0. X is equal to 7. X is equal to -2. Now these are our two x-intercepts. So let's draw a sketch of the quadratic curve. So this is -2 and this is 7. Since our graph says we have to solve the inequality for greater than 0, greater than 0 is above the x-axis. So we have two parts of our answer. So we will write it in two ways, two sets. So x is such that x is less than minus 2, and the answer is union of this and x is greater than 7. So this is our answer with the set notation. So that answers question number B. Moving on to question 9. Find the set of values of x for which x minus 1 into x minus 4 is less than 2 into x minus 4. So we first work out the brackets. We have x squared minus 5x plus 4, and here we have 2x minus 8. X squared minus 5x plus 4 minus 2x plus 8 is less than 0. So x squared minus 7x, 4 and 8 is 12, is less than 0. So our product is 12 and sum is negative 7. So we have minus 3 and minus 4. In order to find the critical values, we equate the inequality to 0. So we have x minus 3 and x minus 4 is equal to 0. So x is equal to 3 and x is equal to 4. So we'll draw the quadratic curve 3 and 4, and since it is less than 0, the inequality, it will be below the x-axis. So our answer is x is such that x is greater than 3 and x is less than 4. And that answers question number 9. Moving on to question number 10. Use algebra to solve x minus 1 into x plus 2 is equal to 18. Hence or otherwise, find the set of values of x for which this is greater than 18. So greater than, we have to solve the inequality for greater than 0. So let's work this out. We have on the left side x squared plus x minus 2. Bring the 18 to the left side. That equals to 0. So we have x squared plus x minus 20 is equal to 0. Product is negative 20. Sum is positive 1. So 5 into negative 4. Our brackets are x plus 5 into x minus 4 is equal to 0. Therefore, x is equal to negative 5 and x is equal to 4. So this gives us our critical values. And now if you want to solve the same inequality, we can solve this by writing the same equation with the inequality sign here. So we have x squared plus x minus 20 is greater than 0. So we draw the quadratic curve minus 5 and 4. Since the inequality is greater than 0, we take above the x-axis values. So we have two sets of values. X is such that x is less than negative 5 and x is greater than 4. So these are our two values. And that answers question number 10b.